Good afternoon, everyone. Actually, I got information from department that this week we have mid-exams. Am I audible to you?
Yes, ma'am.
Yes, ma'am.
This week you have online, mid-one, not mid-one, module one. Module one test is there. So we have to finish the whole module one by this week. So every section is struggling to finish the syllabus. So I'm planning to take this lab for theory. I will finish module one by this 2 hours. Within this 2 hours, I am planning because we don't have time. Okay. So another section, actually, is a section also there, right? B9 section is there.
Ma'am.
Actually, sir assigned me to finish the syllabus. Where actually, what was your last portion where sir completed?
Process model.
Process model started. Process model started, right?
Ma'am.
Okay. So, which process model completed? Waterfall model completed, or it just started?
Waterfall model completed.
Completed, okay. For my section also, I completed waterfall model. So this time is not sufficient to finish the entire module, but we have no option. So these are the syllabus part, the nature of software means the changing nature of software I discussed. The software process, I discussed what was the software process. The main software process means the framework activities that comes under software process. What are the software process? Communication, planning, design, analysis, construction, deployment, right? Those sections comes under software process, means major software process. Other umbrella activities were also there. That too I discussed. That was not common for all the project. It varies from project to project based on the size and complexity. The next is this part we completed, then process model. So we started a generic process model. A generic process model means this is the changing nature of software. Actually, in this PPT, I included the introduction part too. All this part comes under introduction. What is why we are going to study the subject? What is the need of the subject, and what do you mean by software engineering? Those parts comes under introduction part. What is the difference between a hardware product and software product? Also discussed, and definition I discussed. Actually, this is mandatory. Even though that's not mentioned in the syllabus, it's mandatory. Everybody should know what is software engineering is. In previous semesters, they always give this introduction part, but this semester they avoided that part. But introduction is mandatory to start one new subject. So I included those part in my PPT. I will share the PPT today. So these things you should learn, whether it's not in the syllabus or not. This introduction, you should be aware about it. And the nature of the software, different types of softwares we discussed. And generic view means it contains definition, development, maintenance, and these parts we completed. And software process framework contains main process activities like communication, planning, this generic process framework activities. This is one of the topics. So communication, planning, modeling, construction, deployment. This part we completed, and other supporting activities called umbrella activities also mentioned. Next is prescriptive process model. Actually, this is purely based on the syllabus. It is mentioned as prescriptive process model. Prescriptive and prescriptive means, you get some prescription from someone, right? So this model prescribes set of activities, action, task, and what are the quality they have to maintain, quality assurance, and That's why we call it the prescribed set of activities. That's why we call it as a prescriptive. Okay, if the question is like process model, then also you should write the same thing. The prescriptive means, why we mentioned as prescriptive means it contains set of action and activities, task, or whatever it is, the quality assurance things, which is which we clearly prescribe. Suppose if you follow a particular process model, you should follow some set of activities. If you choose another process model, other set of activities are different. That is clearly mentioned. So based on your requirement, you can select any of this process models. In this, there are 3 types of prescriptive process models are there: waterfall model, incremental process model, and RAD model. The waterfall model actually we already discussed in the class. I think HOD section also completed the same portion, process models. Process models actually, in the first one we completed. Anyway, general process is same for all the process model irrespective of the model type. It may be, these are the different basic framework activities are same. And different, these waterfall model, V model, incremental, actually mentioning V model also last class I discussed, but that is not in our syllabus. Just to compare 2 traditional models, I used V model. And incremental, broad, agile, iterative, spiral, prototype model are there. These are the different model types, major model types. Other models also there. In that one, we discussed about, clearly discussed this part, the advantage, disadvantage applications of the waterfall model. This V model is not mentioned in your syllabus, but I already said for competitive exams, you should learn something extra. So V model is one of the important model. So next is, so I did not give any description regarding this V model. Only V model means parallel you are going for testing. Verification and validation phase. For every verification phase, there is a corresponding validation phase too. The next is incremental process model. Incremental process model means we are developing the model in different increments. For example, increment means you can say, you can see here, this is an incremental process model. Here, this different blocks are there, the blocks with different colors: communication, planning, modeling, construction, deployment. I already said these processes are common for all the models. So here you can say, see the increment 1. Increment 1, we have a delivery of first increment, and second increment, increment 2, delivery of second increment, and increment 3 phase started here, and all this after this 5 phases we will deliver the third increment. Means this is the, what is the final product? This is the final product here, the delivery of third increment. But not only this one, we have other delivery also in between, like first and second increment we delivered. Why we are delivered in this way? Because suppose you want before in traditional another traditional model we discussed, like waterfall model. Waterfall model, there is only one final product, that is the fully developed product. But here, before you are going to finish the final product, you can add, because in the first increment it may not contain all the features, all the requirements which mentioned. So this is not a completed product. It contains the basic features, and you hand over this product. Actually, deployment means handover or delivery and taking the feedback. Here, actually, the first increment, you hand over to the customer and take the feedback. So customer will get more idea about the product, because he has one product that is not it's a finished product, but it does not contain all the features he demands. So suppose if he is not satisfied with some of the features, he can recommend, okay, I don't want these features, or I need more features. And again, take the feedback and you will start the increment 2. You can see after second increment also, you will hand over the product to the customer and take the feedback and start the third increment. So multiple increments are here. That is the advantage of this incremental process model. Incremental process model as a process of software development. This is the broken down into multiple standalone module is the important part. Here we have an option to broke into multiple standalone modules. In the previous one, which we discussed, waterfall model, we are not breaking into different modules. Means we will get only one final product, that is after the testing, they will hand over the product. Then what was the disadvantage? The developer has to collect all the requirements before he start the planning. Before he start planning itself, he has to collect all the requirements. In every case, this is not practical. So we are going for multiple incremental. Is it clear? So another thing you can see, it is iterative in nature. Iterative means you can see the same thing, repeat the same steps again and again. It's repeatedly we are going for the same phases. Means the first phase contain all these 5 steps. Again, we are going for the second phase, but again start with planning, planning communication, planning modeling, construction, deployment. Again, in the third phase also, you are again after taking the feedback, means you are communicating with the customer, then going for planning, modeling, construction, and deployment. So at the end, the third increment is not a final one, depends on the product complexity. It will vary, and number of increments are possible till the customer should satisfy. Customer satisfy, you can repeat this process. That's why we call it as iterative in nature. It focuses on delivery of an operational product with each increment. That you should remember. It's an operational product only, not a finalized product with all the requirements we gathered initially. It does not contain all the requirements. Only it's an operational product that you hand over to the customer. You will get a final product in the last increment. Okay. So this is the, for example, the word processing software developed using the incremental model. Word processing means, you know, there is a base version of word processing, and in every increment, they are adding more, and means updation, adding more and more features, and but still you can able to use the first one, the minimum, it guarantee minimum features, right? So that word processing software is an example for an incremental model. Again, suppose if you want to add more features, the existing one is there, you are simply adding the features with the existing one. So the advantage is it's much flexible than the waterfall model. And you will get a final product, means not final product, an operational product very fast comparing to the previous model, the pure traditional model. Then testing, debugging is comparatively easier because it contains small iterations. And the main important point is it can generate a working software very quickly. Okay. So the other thing is customer can respond to the functionality, because if he's not happy with the current functionality, he will get a chance to give feedback. So that is the advantage. And disadvantage is cost-wise. Sometimes the estimation cost may change. Why? Because we are collecting the requirements in between. And this model requires a very clear, complete planning. Planning phase should be very strong. And demand, customer demand will vary, right? So you should be ready to add additional functionality at every. So you may feel somewhat complex comparing to the waterfall model. In waterfall model, there is no chance to change the requirements. Then when we are using, you're already clear where we can use. When demand for an early release of the product arises, suppose your Deadline is after 1 month or 2 months or after 6 months, but the customer need a base model with minimum functionality at present. You can use the incremental model with less features. So the demand of an early release of the product, then you can go for incremental model. We couldn't say one model is better than the other one, because it depends on the model which you're collecting, depends on the requirements. Another case is when software engineering team are not very well skilled or trained. You can avoid some functionality at present if they can't able to implement, and you can postpone that functionality for the next increment. So if the software team is not very well skilled or trained, you can go for it. When high risk features and goals are involved, such methodologies, because you are taking the feedback. So suppose if risky elements are there, you can include in the initial stage, and you can check whether it is working properly, or else you will get enough time to change it. It's not like waterfall. So web application based companies are using incremental model. The next one is RAD model. This is the full form is Rapid Application Development Model, where we are using this rapid. From the name itself, you understand what is rapid. It's short period of time. Within a short period of time, you should develop a product. So what is the important part here? Suppose if you have very less time, are you listening?
Yes, ma'am.
So here the main important part is planning phases, because we have very less time. Very less time is there. So within that period, you have to develop one project. So the planning should be very, very strong here. Then planning is very important. You have a very well planned model, then you can go for development in rapid application development. From the name, you can identify here the problem is time, right? You don't have time to think. You don't have time to change. So what is, you need a very well skilled, trained set of people. So obviously, if the workforce is very strong, definitely you can finish the project within very short span, but at the time, the budget is somewhat high. Means the trained people, they are very expert people, not only the trained. We need expert team. We're an expert team, so definitely the cost is somewhat high. So when you have such kind of requirement, you can go for a rapid application development model. Here you can see different set of, you have to divide the entire team into different team 1, team 2, team 3. And you can give the business modeling, data modeling, process modeling, application. Means here the planning part is very strong, I said. So the modeling also we should do in different set of modeling, like business modeling, data modeling, process modeling. Before models, we never mentioned, we simply mentioned as modeling. But here, each and everything, business model, this is doing parallel. You can see this process is doing parallel. So what is the output? You have a very short time to develop. You will get some 60 to 90 days maximum. Then if the situation is like that, then you can go for rapid application with a very skilled set of labels or developers. So here you can see the business modeling consists of flow of information between various functions in the project. Because here each and every modeling part, we are explaining separately. We are mentioning separately because you don't have enough time to think and replace. So Modeling phase itself, we are divided into business model, data model, process model. Here, from the name, you could identify this is not generating a final product. Here, you will the final product is a model itself. Okay, then the phases you should learn: business modeling. It consists of flow of information between various functions in the project. Data modeling, the information business modeling phase refined into set of objects, and essential for object means when you will learn the UML model, you will understand what is object, how can you take the objects before you start the development. So that we will discuss in the modeling lab. Means in the lab, actually, that entire UML modeling language, we are focusing on modeling part, right? Modeling and designing will diagram. How can you develop an object diagram before you start the actual coding? Okay, so here data modeling also related to the objects. And objects and its attribute you should identify. What is the object and attribute, that you are very much clear, right? Data structure, you learn what is an object, what is an attribute. Attribute means property of that object, right? So that you should identify, and the relationship between the object means that is object diagram itself. What is object diagram? I will explain in the object diagram class. Next, actually now we completed use case diagram, right? Next class I will finish class and object diagram. At the time you will understand. Then process modeling means what are the process you need to create a model, and the process description is created for adding, modifying, deleting, retrieving a data object. So the entire thing is related to the modeling part. Then testing, turnover. Testing part, I already said the testing. We have to do testing independently. Even the prototypes. Prototype means model. We are creating a model. So rapid application development model. You should clear about model, right? Model means it's prototype, not the final product. Modeling is the output of which phase? Which phase? Modeling phase. Modeling phase is there, right? So it's not coming, it's not related to the coding part, before part, that is modeling part. So that application modeling. The evolutionary process model. From what is evolution? Evolution means, you know, the evolution of humankind, or you heard about evolution, right? Same thing. Evolution means there are we have different means versions to meet the business pressure. So that different process model, evolution process model, I'm going to discuss, that is prototyping model, spiral and concurrent development model. Actually, concurrent development model is not mentioned as syllabus, I think. Let me check your syllabus once. In that waterfall model, prototyping process model, evolutionary process model, they mention. Okay, evolutionary process model, this models. Model and unified process model. So here, when you discuss about evolution, you should remember the term iteration. One is incremental and another is iterative. These two terms, you should not be confused. Increment means you have a base model and you are incrementing or adding more and more features in the coming version. That is increment. Iteration means going through the same phase repeatedly. That is iteration. So evolutionary models are iterative in nature. Remember that point. How can you explain this evolution? So going for a prototype model. This is one of the evolutionary process model. It's better to, I think we'll get more idea if I discuss through the diagram. This is a prototyping paradigm. You can see that it starts from planning in the same phases. Phases are same. And that I said before, always, every SDLC's phases are same. It starts from planning, designing, prototype construction, delivery and feedback, communication. So it starts from communication, planning, designing, prototype, construction means a model construction and delivery. Here we don't have a final product. We are constructing a model only, a prototyping paradigm. So you should remember this. This same phase will repeat n number of times. Delivery and taking feedback from the customer. So the communication again. Then again, based on the new requirements, we'll go for a quick plan, quick design. You can see the planning and design phase are repeating, but every time you need a quick design and planning. So yes, designing and planning. Then you can go for a prototype construction. Here we are handover, not the final product. For prototype, we are handover to the customer and taking the feedback. This process will complete. This process will complete only after we collect all the requirements of the customer is satisfied by the model. So this type of models are called prototype models. Prototype means, what do you mean by prototype?
Sample.
It's a model only. It's not the final one. So where we are using this model, it helps the software engineer and customer. Customer means you hand over this model which you developed to the customer in every phase, in every cycle. So the customer and both the developers will get a very good idea about, he can better understand. He can better understand what is to be built when the requirements are fuzzy. If the requirements are not clear, we can go for this model. Customers get an opportunity to see the product in the life cycle, because here the model itself we are hand over to the product multiple times, not single time. So he will get an opportunity to see the product early in the life cycle. So initial prototypes supporting only the basic functionality as desired by the customer. Once the customer figure out the problem, the prototype is refined and eliminating those things. This is what I discussed. The process continue till the user approve the prototype and find the working model set. So here it's purely related to the advantages. Risk is very less. What is the risk? If the customer is not satisfied with the final product which you share, there is a risk is always. So to avoid that risk, we are creating a prototype. Every time we are hand over that prototype model to the customer and taking the feedback from the customer till he is satisfied with the final product. So this is the prototype model. Is it clear to you? This is iterative in nature. Here you could see there is no final product. We are not bothered about final product. Here we are creating a perfect model what the customer needs. Till he is satisfied with that model, we will repeat the process. And once he is satisfied, we will give this prototype for the development. Actual development. Is it clear?
Ma'am.
Yes, ma'am.
So the advantage and disadvantage, I think there is no need to repeat. Once you can go through the slides, slide point, you will, what I said, no, the same thing. Once you go through these points, no need to repeat the slides, right? Go through it once. Any doubts you can ask from this. Any doubts? Advantage, no need of detailed input of process, adaptability of operating system and full machine interaction. Need not know detailed input, the prototype model need not know the detailed input output process, adaptability operating system and full machine interaction. These things you should remember these points, even though it's clear, the points should be remembered and don't mix up. In the development process of the model, users are actively involved because user feedback we are taking very much frequently. So we can say the users are actively involved, and the development process is the best platform to understand the system by the user, and errors we can detect easy and earlier error detection, because the prototype is always getting the customer, so he will come up with his own suggestions. And quick user feedback, identify missing functionality easily. And also this is because of taking feedback, this positivity comes. All these positive parts are because of that. So the risk factor is very less. Disadvantages of prototyping model, the client involvement is more and it's not always considered by the developer. A slow process because we are always taking feedback, right? So obviously it's a slow process because it takes more time for development. Many changes can disturb the rhythm of development team. Rhythm will may be affected. Why? Because the customer feedback, taking customer feedback is good for the customer, but not that much good for the developer. But anyway, it's helped to the final product quality, because customer will be more happy with the product. Okay, once you've done the development, there is no value for the prototype and you can throw. Where we are using, if the requirements are changing quickly and used for developing user interfaces, and it's very good choice to demonstrate the technical feasibility of the product. Technical feasibility you can demonstrate using a prototype, right? Then when it comes to the next model, spiral model. Spiral model is another evolutionary model. You could see the spiral model is iterative in nature. It's like cycle. Here also the phases are same: communication, planning, modeling, construction, deployment. But here you can see in the planning phase, generally we are describing two terms. One is estimation and scheduling, means budget and time we are planning. But here another term is the risk analysis. So in the question, if they clearly mention which prototype model is related to the risk analysis, that is spiral model. Spiral model, main positive part is it's very close with, it's very much focusing on the risk analysis part. So there are multiple methods are there to analyze the risk that we will discuss. In the first module is not there. If it is there in the coming chapter, I think if risk analysis is there, then I will discuss. If it will be there in the syllabus, I will discuss that. Then modeling, analysis, design, and construction means coding, testing, delivery, and feedback comes under deployment. These things, but only difference is risk analysis, that is as part of planning phase. So here the starting phase is from communication as always, communication. Here you can see it's like a ripple. It starts from here, communication, then planning, modeling, then again here, communication, planning, modeling, then again, this is like iterative in nature. So this is proposed by Boehm. And the spiral model is risk-driven. That point you should remember. And iterative in nature, or from the diagram you could clear it is. And it's related to the waterfall model. You can see couples iterative nature of prototyping with controlled and systematic aspect of waterfall. So another question is, which model, which evolutionary process model is a controlled waterfall model? Which one? Spiral model. So there are two main approaches, main features are the cyclic approach is there, anchor point milestone is there. This is cyclic approach actually. You should remember the cyclic approach. Then different circuits. Circuits means a concept development project to a new product development. You have a concept. From the concept you are reaching to a new product development, means something is new. And another is a project product, enhancement product until the software is retired. This is enhancement, already you created one product. Then you are going to enhance it, means maintenance part, until the software is retired from the market, because some software will not be there after some time. So till the product is existing in the market, you can call it as a life cycle of the product. So if it is retired from the market, you should not bother about maintenance. Suppose if it is still existing as a developer, as a company, you have, or it is there, it will clearly mention the agreement. Anyway, if it is there in the market, you have the responsibility to maintain it. So advantages means risk handling, where it is mentioned clearly risk handling, and it is good for large products. Because if the product is large and complex, you can go for it. Why? Because we are handling the risk very effectively, and flexibility in the requirement is there. Why? Because communication is repeating and user requirements we are collecting in every phase. So customer satisfaction is our motto here, because customer can see the development of the product at the early phase of the software development. That's why it is the risk will be automatically low. If the customer is involving and he is suggesting, suppose if you are developing, you have some misunderstanding about the requirements, you will develop something else, not the exact one he needs, right? So you will develop something else, some other products. Even though the product is good, he won't be happy. The client won't be happy because that is not his requirements. So whenever the customer is involving in the development phase, the advantage is that you can develop a product which is risk-free. It means the customer requirement you can satisfy more. So the risk is automatically low. Otherwise, the customer will reject at last. So the disadvantage is complex, expensive, too much dependable on risk analysis, and difficulty in time management. Too much because every time, suppose if the project you are does not face much risk in that, then simply we are wasting time for risk analysis. So when you choose this methodology for a particular product, you should check the requirements. Whether if you are very much clear about one project and you are very experienced in the particular type of projects, no need to go for this model. If you are going for a new something, you are going to implement something new technology or the product, or in the background is not clear to you, you can go for the risk analysis because it supports the risk analysis. So your risk will be low. So application is also same. If every process model, if you are clear about the concept, you can write the remaining things, advantages, disadvantages, applications. So you can think about this part application when there is a budget constraint, and risk evaluation is very important. You should select this model. And for medium to high risk project, we are recommending. For low risk project, you should not go for it because it's completely waste of time. Long-term project commitment. Long-term project always have risk because there is chance of changing the requirements. Today's requirement you are discussing with your requirement engineer. But after some time, your requirement may vary as a client. So long-term project, this is good. And customer is not sure of the requirement, which is usually the case. So that is also another risk factor. So any type of risk it will handle. Then requirements are complex or requirements are not clear if it is a long-term project. And if it's a new product line, and you are not much idea about the requirements and its success, right? Then you can go for it. This methodology. Okay, I need, do you want 10 minutes break? It's 2:50.
Yes, ma'am.
Then come back at 3. It's continuous 2 hours. Okay. And start again at 3 o'clock. Today I have to finish the first module. Take a break for 10 minutes. Welcome back. Next is unified process model. Unified process model, we already learned UML diagram, right? UML, what is UML? What is UML? Unified Modeling Language. This is unified process model. So the same set of people created this unified process model, a rational unified process. It's a software development process for object-oriented models, because you can divide this things into different classes, different objects. Then you can go for the unified process model. It is unified process model is all called as unified model. Both way we can call unified model or unified process model. It's created by Rational Corporation and it is designed, documented using unified modeling language. So this thing we discussed in the lab. The phases, you can see the same phases: communication, planning, modeling, construction, deployment. These are the 5 phases. But here you can see the planning is divided into inception and elaboration. Inception and elaboration we will discuss, because we have to fix the scope. We have to fix the objective of the development. That is comes in planning. Then modeling, construction. These terms you should remember. The requirement gathering. Actually, this is requirement gathering phases. 8 phases are there. And that one, inception, elaboration comes under planning. Then construction. Then transition means if you have an already existing product is there and you need the maintenance, you can go for this thing, existing reusability. Then software increment. After the deployment, you are release the product, and if you want to modify it, you can go for software Hello. B9 students are there, right?
Yes, ma'am.
Okay, I actually right now I got one call from office. So which portions are finished? Waterfall model is completed, right?
Yes, ma'am.
So I started from waterfall model today. I completed. I started from that portion only after the waterfall model. Actually, even for my section also, I completed waterfall model, and you also finished the same topic, right? So I started from the next topic onwards to make sure that sir called me. Then today we completed many models. Are you able to follow me?
Yes, ma'am.
Actually, this topics, every model we discuss single means different sections, means different classes. But this is the first time I'm taking all this together. So I'm not sure whether people can follow me. If you feel any difficulty, please inform. Is there any difficulty following me? But this time we have a tight, sorry?
Nothing.
No difficulty, ma'am.
We have a tight schedule because we should finish the entire topic within this short period. So every single faculty is struggling with the same thing. Then HODs are asked me to finish your topic too. So if any problem is there with the class, you can inform me. Today I have to finish Agile and Scrum also. Hope I can finish. It's 3:08 now. So where is to here? So you, these are the inception, elaboration, elicitation, those processes are there. That is part of requirement gathering. There are 8 phases are there. No need to worry about those phases now. I just, for every one thing, suppose if there is a descriptive type question with any process model, you should draw the diagram. It's mandatory. Whether it's mentioned in the question or not, you should draw that diagram. Okay, so everyone should draw the diagrams. Whatever the process model is, you should draw the diagram. So inception phase means we are communicating with the customer and collecting the requirement. That's what I said. It's a part of requirement gathering. Requirement gathering means requirement engineering itself. One separate part is there. Requirement engineering consists of 8 phases. So those 8 phases we are not discussing here, but in the requirement gathering is very tough, lengthy process. There we are communicating with the customer in different ways, or collecting information from the customer. So at the time we identify the scope of the project and objective of the project. So we are using use case model to communicate with the customer. In the lab, I clearly mentioned what is use case diagram, right? Use case models. Those, even though it's mentioned as diagram, all those are models only. Okay, so it's a part of design and modeling. So those use case diagrams, actually it's a perspection of the user. So we can identify the scope of the project. So the representation is in the form of use cases and objective of the project we are fixing in the inception phase. So project plan, project goal, risk, use case model, project description, all this comes under inception phase. So next is elaboration. Elaboration means planning and modeling, and this is also a part of elaborating. Elaborating means detailed evaluation and revising the existing model. So if you want any modification of the existing use case model, we are doing in the elaboration. The next part is construction. Construction, we already said project we developed and completed. And that part, actual construction is coding. coding part is coding plus testing. Okay, that is the construction part. This is we already discussed. Every single phase, these 5 phases are common, and their goals, their part is same only. So next is transition. Transition means transit the project from the development to the production. Means release in some textbook it mentioned as release only. So we are releasing the product to the public after the testing. Okay, testing completed. The product is okay means you can release to the customer. So there are many type of testing is there. Alpha, beta testing is there. Beta means alpha testing means developer side testing. Beta testing means once you hand over the product to the customer, the same thing we will run in that customer system, and again we will go for the testing, that kind of testing. Then once he's satisfied, okay, you find if the product is functioning well in the customer part also, we can say that product is tested perfectly. So that is beta testing. That also we conducted during the transition time. So why we are conducting the testing? If there is any defects, we can remove those defects and again take the feedback. Removal and means troubleshooting, means debugging the if you have to find out the bugs and debug it, and if you clear all the problems, then only we can mention as a tested okay product. Then you can hand over the product to the actual official handovering, and feedback, you can take feedback from the customer. Right? Yeah, finally, if he's happy with the product, then you could say your transition phase is completed. The next is production. Production is not for all the product. Means once the product he is happy with it, the next is maintenance part. So here it is mentioned as production, right? Deployment. Here it is mentioned as production phase. There is slight difference in the terminologies between this different methodologies. You just remember the software increment. After the increment, you can call for a production. So the remaining communication, planning, modeling, construction, deployment, and some part will vary from model to model. That you should remember. Inception, elaboration is part of planning and communication. These are requirement gathering phases, and construction, then transition, if maintenance, then final production of the things. Means this is the diagram you should remember, and it's more related to the models. This part, that also you should remember. Means class diagram, object diagram, use case diagram, all are modeling, right? So this modeling language it is, modeling process model it is. Okay. So rational unified process is a software development process for the object-oriented models. You should remember that. The next one is concurrent development model. Concurrent development model means here the entire diagram is not mentioned here. Only the analysis part is mentioned here. Means what are the states here? This symbol, these represent the state of activity. Represent the state of one activity. Okay, so that's why we can call it as a state diagram. It represents the state. State is always representing using this symbol. So the entire 5 stages are not mentioned here. Only analysis part is mentioned here. Then what are the states the product is going through the analysis activity? So the first is here under development one product, it await for the changes. If there is any changes are there, then under revision, then review, then you will get a baseline product and it is done. And again, it will wait for the changes, and this process will repeat. This part is cyclic. It's continuously happening. So under development, then there is no changes, then it's under review, baseline, and done. So this option, if there is changes are recommended, we'll do the changes and do the review after that. And if there is no changes recommending, it will just go for the review and you'll get a baseline product. So this represent the states of operation. The concurrent development model represent the states. It's a state chart diagram actually. So the concurrent development model is called concurrent engineering. Here the communication activity is completed in the first iteration and exit in the awaiting changes state. Actually, the communication part is not showing here. In this diagram, it's not showing. That none means communication part is already completed. So it's not mentioned here. So the none state represent that part. Before analysis part is showing that. That's why I said not like other diagrams which we drew. In that one, every phases, every stages we mention in the diagram, but here only the analysis activity is mentioning. Analysis comes after the planning, right? So communication and planning here represent none. It's not represented here in the diagram. After remaining analysis part is showing here. So the communication activity is completed in the first iteration and exit in the awaiting changes state. And then modeling activity is completed its initial communication, then go to the underdeveloped development state. Then, so if the customer, if he wants any change in the requirement, then modeling activity move from the underdevelopment state to awaiting changes state. This is the underdevelopment state. If there is any changes need or the requirement is changed, then we are going for the states. State, that term you should not forget. State is representing here, and that is, this is a state diagram. This is not the other, in none of the diagrams we represent the states. So there are so many. Here you can see this symbol is rectangular. It represents the phases of operation. Phases of operation. Here it represents the states of operation. Okay, if you draw the entire 5 phases states means it's very complex diagram. That's why here only mention the analysis part. Okay, is it clear? So when you draw the diagram, you don't need to draw the entire thing. Analysis and modeling also comes under same phase. So either you can represent modeling activity, design activity or analysis activity. Is it clear?
Yes, ma'am.
Yes, ma'am. Yes.
So here you can see the arrows. Arrows means events represent when it comes, when one particular event happens, the state will change from one state to another state. Means an external event happens, it will vary from one state to another state. For example, when you are in under development state. Suppose if any changes, any requirement comes, then it is going to awaiting state changes state. Otherwise, it is going for the direct review. So it depends on the external trigger, external events. If a particular event happens, it go to the particular state. If it does not happen, it go to another state. So that is mentioned in the diagram. So advantage, the model is applicable to all type of software development process. And it is very easy, it is very understandable, and it's usable, and taking the immediate feedback, an accurate picture of the current state of the project. You should remember this. None of the life cycle diagrams give the state of the project. Only this concurrent development model give the state of the project. So if it is in a particular, we can clearly understand in which state at present the system is. Okay. Then disadvantage. What is the disadvantage? We should remember the status of different activities. There are multiple activities. That's why I said that we couldn't draw the entire diagram here. We are mentioning the states, but it's very hard to remember the status or state of the operation. So that is one complexity. It needs better communication between team members. That is another disadvantage. The next is, so all the models we completed. All the process models we completed. Today we discussed and waterfall model we discussed in the last class. After that, incremental process model means different increments are there. We are developing the product through different increments. Next is RAT model, rapid application development model, then prototype model, then evolutionary process model, spiral model. Actually, that 3 categories are there, right? What are they? These 3, the prototype, spiral, concurrent development model. All these comes under evolutionary process models. Okay, so we discussed these 3 models, concurrent development models. Then other than these 3 models, unified process model is there. Unified process model is there. All other models we completed. So this is the first part of the. Then one more topic is there in SC syllabus, that is agility and process. We can see the syllabus. I will share the syllabus once. This is the syllabus. In that syllabus, we completed the nature, software process, software engineering practices, generic process model, prescriptive process models. In that one, the waterfall model, prototype process model, evolutionary process model, and unified process model we completed. The next is agility and process. So agility and the cost of change, and agile process and Scrum, I should discuss now, the last 30 minutes. Is there any doubt? The first part, the introduction to software engineering and process models, is there any doubts?
No.
No doubts. Then comes to the next part. Agility. Agility means, before coming to this, discuss about agility. Okay, actually I discussed this V model with my students. The B9 students may not V model. You just check the V model here. This is developer life cycle, and the only difference is that here we are doing the testing parallelly, like business requirement specifications, system requirement specifications, then high level design, then low level design, then coding. Means it starts from from outside to inside. Means first we should collect the requirements. The requirements may be either business or system requirements. So once you collect the requirements, you can go for acceptance test and integration testing. So this is parallel. This testing phase is parallel with this phase, developer life cycle and testing. So you can, from this diagram, you could clear this. Testing is very much important in this diagram. Testing is very important role in this diagram. So you could easily find out the errors. If something is there, you could find out the errors in the initial. So debugging is very strong in this model. So high level design means component testing you have to go, and then low level design means you testing. Means low level design means a lowest level, even the function in a module, that designing is the lowest level. Then higher level means the outside component designing. Deployment designing comes under higher level design. So for each and every designing, you are doing a testing in parallel. Unit testing means module testing. The lowest functional testing. Suppose if the boundary conditions are satisfied or not, if the loop is correct or not. So those internal details you are checking in the unit testing. And next is component testing. Once you develop one particular component, you will go for the component test. Then component contain multiple modules. So next is integration testing. Integration testing means when you integrate these different components, you are going for a system integration testing. Means modules are integrated together, then still you are checking whether these modules are togetherly working perfectly or not. Then last one is acceptance testing. Acceptance testing means whether it satisfies the business requirement or not. Business requirement is different. Means we should get a business value. Means we should market this product which we developed. So that last testing is called acceptance. Acceptance testing means the customer should be accepted. Means who will done this acceptance? Customer with developer. So customer is satisfied or not, whether he accepted the final product or not. That is the acceptance testing. So the testing is doing parallelly with the development. That is the V model. Just because this one I explained for my section, that's why I repeated here. So next is when you discuss about agile process, agile software process, I will give a, actually the introduction part is not mentioned in your syllabus, but you should know what is it. Then only you can. Okay, where we are applying this agile. Are you listening? Are you following me?
Yes, ma'am.
Okay, what is agile? Agile means quick moving. Quick moving means if the requirements are changing very frequently and it is changing very fast, you can go for agile software development. That is another development methodology. Agile is a software development approach where a self-sufficient cross-functional teamwork on making continuous deliveries through the iterations and evolve throughout the process by gathering feedback from the end user. This is the definition of agile. So what do we mean? Suppose if the requirement is changing very frequently, you have to include those requirements, and even in the late phase, means development phase also. You should be ready as a developer. You should be ready. Some type of projects need this agility. Agility means changing nature. So this means initially when the project starts, the customer is not even he does not know aware about the requirements, then he will approach, we recommend agile software model, agile software methodology, because with just 20% requirements, we can start a project using agile. Agile as a the developer should be ready to take the requirements at any time, even during the development time also. But we won't recommend to collect the requirements in the development time because development cost is very high if you collect the requirements in a late phase. But still, that is the nature of agile models. We should be ready to collect the requirements even in the final stage also. These are some agile promises: on-time delivery product without cost overrun, high-quality product, good design, customer-first approach. This is the main thing. Customer-first approach. Here, customer is the key. Customer wants to change the requirements at any time. As a developer, we shouldn't say, I'm not ready. This is very late phase. I can't able to change right now. We should not say. If any project needs that type of change in requirements, then we should go for this agile model. So these are some values, agile values. It's very important. Individuals and interaction over process and tools means individuals and their interaction, we give more priority than the process and its tools. Then working software over comprehensive documentation is good, but here we give much importance to the working software because we should hand over the product, the working software, not the final one. Working software, we are ready to hand over to the customer. Next is customer collaboration over contract negotiation. Contract negotiation means as a developer, you have the right to negotiate with the customer, but we give much importance to the customer collaboration. Collaboration work than negotiation, and responding to change over following a plan. The plan is mandatory and it is good. Even in the Agile also there is a plan. You can follow the plan, but more important, you should respond to change than following a plan. Okay, you are saying to your customer that I have a plan, I can't change my plan now. Whatever the requirement is, I can't add in this plan because the plan is important. But no, in Agile, plan is there, but plan should be, we should be ready to change at any time. So these are the 4 Agile values. Students, are you listening? Because today I have to finish lot of portions. Yes.
Yes, ma'am, listening.
So these 4 points are there. You should remember. Agile manifesto is not there. Then these are the Agile practices, Agile methodology. Different Agile methodologies are there. Scrum, extreme programming, DSDM, feature-driven development, and many others are there. Agile methodologies are there. But in your syllabus, it's mentioned only Scrum. So I will teach you Scrum. This is like the methodologies which I explained before: evolutionary process models, prototype model, concurrent process model. Same. This is comes under Agile. Agile means the requirements, the remaining are traditional models. Here we should satisfy the customer. We are ready to satisfy the customer by accepting his requirements at any time. So those type of projects comes under Agile model. And Scrum is important. We'll discuss. Should collaborate. These different team members should collaborate, and there should be a Scrum Master and a program owner is there. And you can see the user stories, epics, business features, business process architecture design means we should collect the requirements from the customer and you should create the user stories or use cases. That part and designing part comes here. And the product owner is there. Product owner means the one who spent the money for creating the product. And you can see there are some meetings are there, retrospective meetings are there that I will discuss you. So means it's a checklist, whether have you finished this thing or not. And if there is any backlogs, you can go for the sprint. Sprint means I will explain you. So one Scrum Master is there. You just remember now what are the different roles in this roles. So here the main thing is that here we are going for everyday meeting and after some 31-month meeting or something like that. So meeting is very important in Scrum. Means collaboration is very important. Daily review meeting will be there and monthly review meeting will be there. So meetings are there. There we will check the progress. So this is the main thing, and we will check the backlogs. If something is there behind, we have to include that in the upcoming session. So Scrum is one of the implementation of Agile methodology. Okay, here in which the incremental build, what in the incremental model I already said, we have different increments. So these increments we are delivered to the customer in every 2 to 3 week time. So what is the advantage? The customer will get a product, an increment, or not the final one, but a working product in every 2 to 3 week time. So this is used in the project where the requirement is rapidly changing. Requirement is rapidly changing. You can go for it. In Scrum, collaboration is very, very important because we have very limited time. Within the limited time and the requirements are changing very frequently. The collaboration between developers and the customer. We don't have time to call and suppose if the project is very complex, they will assign one on-site customer itself to take the feedback. So in Scrum, collaboration is achieved in daily stand-up meeting. That meeting you should remember with a fixed role assigned to the Scrum Master, Product Owner, team members. So everyone has their own roles. The Scrum Master is there, Product Owner is there, the one who spent money is called Product Owner, and team members, everyone have fixed assigned roles are there. They should come up with daily stand-up meeting, reviews are there. So not too many changes needed while implementing Scrum process. So the main part is deliver. We can able to deliver working software, a working product within 2 to 3 weeks time, and many increments are possible, and when the requirements are changing very frequently, you should go for it. After each sprint, the build is delivered to the client for the feedback. So this build means incremental. What you completed right now? That is your build. Build 1, build 2, build 3. Like n number of builds are there till you reach the final product. A demonstration of the functionality is provided at the end of every sprint. So you can take the feedback from the customer for the next sprint. That meeting is called the sprint. One complete cycle we call as a sprint. So daily sprint meeting is there that we will conduct and take the review and feedback and decide for the future progress. That process is happening continuously. So working software is not an elementary measure here. Okay, so who will manage these things? The Scrum Master. Scrum Master will monitor this meeting. Scrum team focused to deliver maximum business value from beginning onwards because we are focusing on the market value. So Scrum principles are self-organization, collaboration, time boxing, iterative development. Self-organization means because everyone is owner of the product. That feeling should be there because it's a collaborative work. You shouldn't say that part is developed by you. That's why it made mistake in that part. You should not complain. It's a shared ownership. So that is called self-organization. The collaboration means between all members, there should be a collaboration. It's a collaborative work. So suppose if there is any problem in between the team members, you could not achieve these things within a short period of time. The next is time boxing. Time boxing means how time is limiting constraint in Scrum method. Time is very important because I already told you within 2 to 3 weeks, every time you should be ready with a working product, right? So the time boxing, you divided the entire time into different boxes, means within that particular time box, you should finish one set of functionality. So if you can't able to finish that set of functionality, we will add those functionality as backlog. Okay, so this we are come up in the meetings in daily Scrum meeting with our progress. An important role of time boxed. This daily sprint meeting is there and review meetings are there. Then in this meeting, we will come up with our progress, and if we are not in right ways, they will suggest you some other modifications. That's why Scrum, that is a role of Scrum Master. So it's an iterative development. Again and again, you are taking the feedback from the customer and repeating the process. That's why we call it as iterative development. So these are the Scrum principles, and this is the Scrum diagram. This diagram contains all the topic. This is the burn down chart. Burn down chart means how much you completed, how much features you already completed, and how much are pending. That list is that is burned down chart. If it is already done, you will mark that thing. And Scrum Master will monitor the entire thing. So Scrum Master, Product Owner, and developer teams are here it's Scrum Master guide the team and keep master. And the stakeholder means everyone belongs to the directly or indirectly connected with the product is called stakeholders. And the product owner is the one who spent money and he will conduct the review meeting. And this review meeting has a strategy. The product owner created for product backlog means that is a wish list. And Scrum team conduct a sprint planning session. Actually, this topic is very vast. It's very tough to finish within this short time. I will share this notes with you. These are the three main Scrum roles: product owner, Scrum Master, Scrum team. Scrum artifacts means these are the work products. Work products means product backlog is the backlog contain ordered list of what is needed to improve the product. That set is called backlog. Then sprint backlog means sprint goal, the set of product backlog items which is selected for the particular sprint. Means the entire product, from the entire product backlog, we are selecting some items for the particular sprint. And increment. Increment is the build. There are multiple build are there to finish the final product. So advantage is you can deliver the product very quickly. Complete the project deliverables quickly and efficiently. And effective use of time and money. Then here, large project divided into manageable sprint. You are checking the backlog, and that part is called sprint review meet. Okay. And who will look after this meetings? A Scrum Master. So the team get clear visibility through the Scrum meeting, and Scrum adopt the feedback from the customer and stakeholders. Stakeholder means the persons who are directly and indirectly communicate with, means a part of the development is we call as stakeholder. And the individual effort of each team member is visible during daily Scrum meeting. Means daily Scrum means every 24 hours we are going for a sprint meet. Okay, so if you are not means to measure the progress. If they are not satisfied, the Scrum Master and the team members are not satisfied your pace, they will ask you to change your methodologies, or they will give you some advices. So this is the burn down chart. You can see the ideal work real-time line is there. This is the ideal time, but there is an actual work remaining line is there. That will vary, right? So this is the actual, this remaining one. So that one we will plot in the form of a chart that is called burn down chart. This is a graphic representation of how quickly the term is working through a customer user story. Okay, it shows the total effort against the amount of work for each iteration. That part you should remember. It shows the total effort against the amount of work for each iteration. That we will plot in the form of a graph. You will get like this. This is the ideal one. And but you can't able to achieve this ideal one, but there will be a slight difference between the actual one you attained, that we have to plot in the form of a graph called burn down chart. So this we will display this chart to everyone, then everyone can see the this updated, everyone can see the our progress. And based on that, we can make changes. Then what are the events in Scrum? One is sprint meet. Sprint meet means basic unit of work for a Scrum team. So we assigned one sprint to a team member. This is called a sprint. These terms you should not forget. Sprint means it's a basic unit of work for the Scrum team. So we are analyzing those basic unit of work, that is the sprint. We are analyzing the sprint called meetings called sprint review. So to show what work has been completed, that we are checking through the review meeting. Review means when you are going for a project review, the project they're analyzing in review what they're analyzing, how much you completed, right? How much work you have finished, that they are checking. Same thing in sprint review also, they are doing the same thing. Okay. Are you listening me?
Yes, ma'am.
Then coming to retrospective meeting. Retrospective meeting means the team review the completed goals of the finished sprint. Means he will write the good and bad things, because we can use the retrospective meeting documents for the further, suppose if you want to make if you want to do the same type of project, or means in agile methodology, this will be an input. Means you won't repeat the same mistakes again. So we will document each and everything, even the meetings also we will document. And that sprint retrospective. Retrospective means, you know the word meaning, right? So the term review the completed goal of the finished sprint and write the good and bad. Okay, that part is called sprint retrospective. This will help you to avoid the mistakes in future. So it will during this part, it will identify the possible process improvement and generate a plan to implement in the next sprint. So within last 10 minutes, I will share this notes with you. What about B9 students? I will share to Chantana. Okay.
Okay, ma'am.
Then next part is this one, agility and cost of change in software engineering. So here, the only difference is that in agile methodology, we are accepting more change in the requirements. Okay. So here you can see this is a curve. This is the development schedule progress. And this is the development cost. This is expecting. What we are expecting is the idealized one. You can see in the dotted line. This is an idealized cost of change using agile process. Suppose if you are going on for an agile methodology, this is the cost of change. But you can see the cost of change using an agile process in reality is this pink color. Means it start initial development cost is less, and after some time it will increase and it's going to be steady. That is the ideal case. But in actual case, suppose agile, what is the thing we are requesting the changes, right? Agile team members are always ready to accept changes. So, but still, if the requirements we are collecting in the final stages, the development cost is very high. it will increase than you expected. This is the expected one, but you can see this is the difference. It will increase like it's like an exponential. This is not completely an exponential, but you can see not a steady one. It's increasing. But next is cost of change using conventional software process. Conventional software process means the other methodologies which I discussed other than the Agile. Scrum comes under Agile. But the other methodologies, there is a flexibility, but not that much. It does not accept a huge change in the requirement in the final stages like construction phase. Till analysis design, okay, up to some extent we can accept the requirements, but it's not that much supportive in other conventional process. There you can see, suppose if we change, if we accept the change in the final phase, you can see there is a huge difference in the budget, means development cost. You can see this is the actual one we are expecting, but here it's a, so comparatively comparing to this conventional methodology, Agile take less cost. Okay, it's almost 50%, less than 50%. So this is the actual one. This is the conventional methodology development cost. This is the Agile methodology development cost. So almost 50% reduction in the acceptance, change in requirement. So Agile process is characterized in a manner that addresses number of key assumptions. This is actually what I explained. Agile process. What is Agile process? And Agile principles. There's 12 principles you should remember. Okay. These things I already explained in another way in the previous, like these 4 values you should remember: competence, common focus, collaboration, decision making, ability. So the next is, this is the last topic, agility principles. So are you listening the class?
Yes, ma'am.
Yes, ma'am.
So 12 principles, only you are listening. What about others? I'm not getting other responses. Hello, others are listening or not?
Yes, ma'am.
Actually, this was very tough for me to finish these many topics within 2 hours. I tried my maximum to finish. So I definitely will finish the topics. But if I get more time, I can give a better explanation. Means it needs more time to explain in detail. Actually, I'm summarizing the contents. So please cooperate. So Agile process, right? Okay. Agility principles. These 12 principles you should remember. One is our highest priority to satisfy the customer through early and continuous delivery of valuable software. That we discussed. Our main motto is to satisfy the customer by accepting the requirements even in the late phase and give continuous delivery. Means different increments with base version, with modified version of more functionalities in the coming increments. That is our main motto, highest priority. Then welcome changing requirements even late in development. That is what I said in Agile. Agile means its main difference from the conventional models. We are welcoming changing the requirement even in the late phase also. Next is deliver the working software frequently from couple of weeks to couple of months with a preference to a shorter time scale. Means our time, we already set one time box and we are working very tight with a tight framework, and that's why we can deliver the working software very frequently. Very frequently, we should give not the final one. Just to mention us working software, not a software with fully fledged software. It's not a fully fledged software. It's not satisfy all your requirements, but you can able to deliver a working software. Business people and developers must work together. The collaboration, the point I already mentioned, collaboration between all the stakeholders is mandatory, and build projects around motive of differences between the people, because we have limited time and we need to face a lot of challenges because of accepting the requirements even the late phase. So build the projects around motivated individuals. Self-motivated people should be here. We don't have even time to motivate others. So the most efficient and effective method of conveying information to and within the development team is face-to-face conversation. The communication is very important. The 4 agile values you should remember: communication, collaboration, those things only mentioned here. Next is working software is the primary measure. That I repeated many times. Agile process promotes sustainable development. It should be sustainable. The development should be sustainable. That should be monitored. And continuous attention to technical excellence and good design enhances the agility. Technical excellence is mandatory because we have tight framework, time limit is there. So you should meet the deadline. So continuous attention to the technical excellence is mandatory, and simplicity is always in every agile models, methodologies. One of the prime factor we are giving, prime importance we are giving to simplicity. Simplicity is an art of maximizing the amount of work not done in essential. Means, see, if the model, because our main motto is to change in the requirement, to implement that change in the requirement. If it means frequent modification is needed, how can you modify a existing system? If the system is simple, if the design is simple, if the planning is simple, if the coding is simple, then only you can modify it easily. Otherwise, modifying something which you already done in a very sophisticated way is very difficult, right? So simplicity is the art of maximizing the amount of work not done is essential. Now, means simplicity is very, very, very important in case of Agile, because modification is mandatory thing. Then the best architectures, requirements, designs emerges from self-organizing teams. At regular intervals, the team reflect on how to become more effective, then tunes and adjust its behavior accordingly. So these are the 12 points you should remember. It's simple points only, simple things. Once you go through it, definitely you will get. But the points is important. You should recollect, remember and recollect. So these are the main things. I completed the portion by 3:59, means exactly my timings was correct. So once you check with the syllabus, did I complete all the topics? Look, agility and cost of change, agile process, Scrum. This is the last topic. So agility and process we completed. The process models which we discussed here are the conventional process models, and agile process models also we discussed, and in that one different classifications are there, but only Scrum is mentioned in your syllabus. So I explained the Scrum and cost of change. Agility is the topic. So the basic introductions I gave. So the whole topic I covered as per the syllabus. Is there any doubt?
No, ma'am, no doubts.
All of you listen. Okay, then how many of you listen the class? Please raise your hands. Because today I completed lot of portions. This time is not sufficient for these many topics. I know there was a limit. So if you have any doubt, you can ask me from the module 1. So I will share the 20. How many students out of 85? I got 20 responses. I got 20 response out of 85. What about the remaining students? Okay, so this is the first module. You have an exam. By next week. Module 1 test is there, so prepare well. If you have doubts, ask me now. If you don't have any doubts, you can leave. So I will inform HOD sir. This portion is completed. The module 1 is completed. From J students, B9. Anyone from B9?
Ma'am.
Okay, so today I'm going to inform him that we finished the first module. Okay.
Okay, ma'am.
Any doubts? You please ask me.
No, ma'am, no doubts.
So I will share for B9 students, I will share the notes to Shantana. Okay.
Okay, ma'am.
Okay, then thank you. Bye.
Thank you, ma'am.